In this video, we'll be seeing the trigonometric ratios of some select angles. Now, there are 5 angles that we need to remember specifically because they've been asked again and again in various questions. Those angles are 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. So, in this lecture, we'll be seeing what are the values corresponding to each of these 6 trigonometric ratios that we have already studied in the previous lectures. Now you all know that sine is the ratio between perpendicular upon hypotenuse, cos is base upon hypotenuse, and so on. Now I'll start with my first angle, and that angle is 0 degree. Now I need to make this angle theta as 0, because if I make this angle theta 0, then the values would be corresponding to 0 degree. So I have to make this angle theta as 0. And if I think of making this angle 0, I need to drop the hypotenuse in this triangle, which is AC, to overlap with the base, which is AB here. So if you're wondering how we'll do so, we'll just be dropping AC on AB. So this would drop like this, then this, then this, and the drop will finally end here when AC would drop to AB, and at that moment I'll get AC equal to AB. Hence at that moment the hypotenuse would be equal to the base. Now what would happen to the perpendicular? The hypotenuse has become equal to the base. Now since the drop is happening, the length of the perpendicular is reducing slowly, and when AC would match AB or AC would overlap with AP, the length of the perpendicular would have dropped to 0. Therefore the perpendicular would drop to 0. So this is the condition for angle theta to be equal to 0 degree. Now we have all the trigonometric ratios written on the right side, so we'll just calculate one by one. So I'll put theta as 0 degree. Now sine is the ratio between perpendicular and hypotenuse. The perpendicular has become 0 and the hypotenuse is h. 0 upon anything is 0, and sine of 0 degree is 0. The next is cos of 0 degree. Now cos is the ratio between base and hypotenuse. Now base and hypotenuse have become equal for this angle, so it is base upon hypotenuse. The base and hypotenuse have become equal, so I can replace the hypotenuse by base. It would get cancelled, and the answer is 1. The next trigonometric ratio would be tan of 0 degree. Now tan is the ratio between the perpendicular and the base. Now perpendicular upon base, the perpendicular has become equal to 0 and base is B. 0 upon anything is 0, hence tan of 0 is 0. The next is cosec 0. Now cosec 0. Cosec is the ratio between hypotenuse and perpendicular. Hypotenuse is h, but the perpendicular had come down to 0. Anything upon 0 is considered to be not defined or is considered to be infinity. The next is sec. Now sec is the ratio between the hypotenuse and the base. Hypotenuse and the base. The hypotenuse and base have become equal, so I can replace h by b, and this would get cancelled, hence the answer is 1. And the last is cot of 0. Cot is the ratio between base and perpendicular. The perpendicular has become 0. Anything upon 0 is not defined or will consider it to be infinity. So we have to remember the outcomes. Sine of 0 is 0, cos of 0 is 1, tan of 0 is 0, cosec of 0 is either not defined or we can call it as infinity, sec of 0 is 1, and cot of 0 is again not defined or infinity. So we'll move to the next angle. So again I have the same triangle ABC. This time I need to find the 6 trigonometric ratios for theta being equal to 90. Now to make this angle theta as 90, you can see that I'll slowly move A towards B. If A starts to move towards B, you can see that slowly and slowly this angle would start to increase, and once it is just below C or just adjacent to, this angle has already increased to 90. So for this angle theta to become 90, this hypotenuse should move and overlap with the perpendicular like this, and when this would happen, the base would become 0. So for theta is equal to 0, for theta is equal to 90, we get the condition that hypotenuse is equal to perpendicular and the base has become equal to 0. Now we'll put this condition one by one in these 6 trigonometric ratios. So sine of 90. Now 90, sine of 90, the sine is the ratio between perpendicular and hypotenuse. So it would be P upon H, but we have seen that for angle 90, H is equal to P. The answer would be 1. The next is cos of 90. Cos is the ratio between base and hypotenuse. The base has become equal to 0, hypotenuse remains H, 0 upon anything is 0, hence cos of 90 is 0. The next is tan of 90. Now tan is the ratio between perpendicular and base. Perpendicular is P, while the base has become 0. Anything above 0 is either not defined or we call it infinity. The next is cosec of 90 degree. Cosec is the ratio between hypotenuse and perpendicular. Since the hypotenuse and perpendicular are same, I can replace H by P. P and P would get cancelled, hence the answer would be 1. Hence cosec 90 is 1. The next would be sec of 90 degree. Now sec is the ratio between hypotenuse and base. H remains H, but the base has become 0. Anything upon 0 is not defined or infinity. And the last would be cot of 90, which is base upon perpendicular. Base upon perpendicular. Now since the base is 0 and the perpendicular is P, 0 upon anything is 0, hence cot of 90 is 0. Therefore we have found out the 6 trigonometric ratios corresponding to 90 degree. We move to the next angle. This time the angle that we take would be 45 degree. Now in this triangle ABC, I need to make this angle theta as 45. It can be easily been seen that this is 90. If this is 45, this would also be equal to 45, since the sum of the 3 angles would be equal to 180. Now for this angle theta, BC is the perpendicular, AB is the base, and AC is the hypotenuse. Now since this is an isosceles triangle, since 2 angles are 45, both the angles are 45, hence we know that side opposite equal angles are also equal, hence P and B would be same or equal, hence for 45 degree we get the condition that P is equal to B. Now let's apply Pythagoras theorem. So let P be equal to B is equal to X. So I have named this as X and I have named this also as X. So I have let the length of the perpendicular be X and let the length of the base be equal to X. Now applying Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. This would give me H square is equal to, the perpendicular is also X and the base is also X. I'll get H square is equal to 2X square. I'll get H is equal to root 2X. So I am putting in brackets the 2 conditions that I have got. First is P is equal to X, B is equal to X. Hence under the given circumstance of making this angle 45, hypotenuse has come out to be root 2x. I'll one by one find out all the trigonometric ratio. The first would be sine of 45 degree. Now sine is the ratio between perpendicular and hypotenuse. The perpendicular is x and the hypotenuse is root 2x. This would be x upon root 2x. This would cancel and the answer would be effectively 1 by root 2. The second would be cos of 45 degree, which is base upon hypotenuse. Now base is x and the hypotenuse is also is root 2x. Hence again this would calculate to 1 by root 2. The third would be tan of 45. Now tan is the ratio between perpendicular and base. The perpendicular is x and the base is x. So this would be x upon x. The answer would come out to be 1. The fourth ratio would be cosec. Cosec of 45 degree. Now cosec is the ratio between hypotenuse and perpendicular. Hypotenuse and perpendicular. The hypotenuse is root 2x and the perpendicular is x. Hence this would come out to be root 2. The next would be sec of 45 degree. Now sec is the ratio between hypotenuse and perpendicular. The hypotenuse is root 2x and the perpendicular is x. Hence again the answer would be root 2. And the last would be cot of 45. Now cot is the ratio between base and perpendicular. The base is x and the perpendicular is x, and this would again calculate to be 1. So sine of 45 is 1 by root 2, cos of 45 is 1 by root 2, tan of 45 is 1, cosec of 45 is root 2, sec of 45 is again root 2, and tan of 45 is 1. Next angle that we'll be seeing would be 30 degree and 60 degree. They are done together because their proof requires us to consider a equilateral triangle. So I've drawn an equilateral triangle ABC. In an equilateral triangle, you know that all the three sides are equal. So I'll for some time let the three sides be equal to x. So I'll put the length of each of the sides equal to x. So all the three sides are equal to x. And we also know that each of the angles in an equilateral triangle is equal to 60 degree. Now what I'll do is that I'll do a construction. I'll drop a perpendicular from vertex A to the base BC and let this be D. So I have AD, and since it's a perpendicular, this angle would be 90 degree. Now using congruency, I can easily see that this triangle ADB and ADC are congruent. Hence these two angles would be equal, this angle and this angle, and since they are equal and their sum is 60, they individually would be 30 degree and 30 degree. So if I pick the triangle ADB, which is something like this is B, this is D, and this is A, this is 90. I know that this is x because I've put this as x, and since BD, these two triangles were congruent, the length of BD and DC would be equal, so BD would be half of x. This would be x by 2. Now I don't know AD, so I'll find AD using Pythagoras theorem. But before I do so, this angle is 90, angle D, angle B is 60, and angle A of this triangle is 30. So if I'm able to find AD, I'll be able to figure out the trigonometric ratios for both 60 degree as well as 30 degree using this triangle. So using Pythagoras theorem, I can see that AD square plus BD square, which is perpendicular square plus base square, is equal to hypotenuse square, which is x here, AB. Now AD is something that we need to find out. BD is x by 2 and this is equal to x square. So AD square plus x square by 4 is equal to x square. AD square is equal to x square minus x square by 4. From here we will get AD square is equal to 3x square by 4. I'll get AD equal to root 3 by 2x. So I'll put AD in this figure as root 3 by 2x. So I'll pick this triangle once again, and using this triangle I'll be able to find trigonometric ratios of both 30 degree and 60 degree. So I'll make this triangle once again. So the triangle was BDA. This angle was 90. This we calculated as root 3 by 2x, which was 80. BD was x by 2, and this is x. This was 60 degree angle, and this was 30. So I'll take both the angles one by one. So I'll first take 60. Now for angle 60, I can see the perpendicular is of the length root 3 by 2x. The base is of length x by 2, and the hypotenuse is of length x. Therefore, sine of 60 degree, which is perpendicular upon hypotenuse, would be equal to perpendicular is root 3 by 2x upon hypotenuse is x, and the answer would be root 3 by 2. Similarly, cos of 60 degree, which is base upon hypotenuse. Now base is x by 2 upon hypotenuse is x, and this would calculate to 1 by 2. The next is tan of 60 degree. Now tan is perpendicular upon base. The perpendicular is root 3 by 2x, and the base is x by 2. 2 and 2 would get cancelled, x and x would get cancelled, and the answer is root 3. The next would be cosec of 60, which is hypotenuse upon perpendicular. Now the hypotenuse is x, and the perpendicular is root 3 by 2x, which would come out to be 2 by root 3, or we can simply use the fact that cosec is the reciprocal of sine. So since sine was root 3 by 2, cosec has to be its reciprocal. Next would be sec of 60 degree. Now I'll use the concept that sec is hypotenuse upon base, which is effectively the reciprocal of cos, and this would come out to be 2. And the last would be cot of 60 degree. Cot being the reciprocal of tan, we know it is base upon perpendicular, so this would come out to be 1 by root 3. I'll use this triangle once again, and this time I'll take angle 30. So I'll draw triangle BDA once again. This was B, this is D, and this is A. This was root 3 by 2x. This was x by 2, and this was x. So AB was length x, BD was length x by 2, and AD was length root 3 by 2x. Now for this angle was 90, this was 60, this time I am picking this angle, which is 30. Now for angle 30, the perpendicular is the side in front of it. P would be equal to x by 2. The base is the adjacent side, which would be root 3 by 2x, and the hypotenuse would be of length x. Therefore, starting with sine again, sine of 30, which is perpendicular upon hypotenuse. The perpendicular is x by 2, and the hypotenuse is x. This will come out to be 1 by 2. The next would be cos of 30, which is base upon hypotenuse. The base is root 3 by 2x, hypotenuse x, and it would cancel and simplify to root 3 by 2. The next would be tan of 30, which is perpendicular upon base. Now perpendicular is x by 2, and the base is root 3 by 2x. This would get cancelled and give me the answer 1 by root 3. The fourth would be cosec, which is simply the reciprocal of sine. Hence it is hypotenuse upon perpendicular, hence it would be reciprocal of half, which is 2. The fifth would be sec of 30, which is hypotenuse upon base, and sec is the reciprocal of cos. Hence doing the reversal, the reciprocal would be 2 by root 3, because cos was root 3 by 2. And the last being cot of 30 degree. Now cot is the reciprocal of tan. It is base upon perpendicular. Now doing the reciprocal of 1 by root 3, the answer would be root 3. So we have seen that out of the 5, we have seen that 5 trigonometric ratios corresponding to 5 important angles: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And to summarize the outcomes that we have got and to remember them, we can summarize the whole outcomes into this particular table, which shows us the 5 important angles: 0, 30, 45, 60 and 90. The 6 trigonometric ratios: sine, cos, tan, cosec, sec and cot. And in this table we have consolidated the outcomes for each of the angles. So this is a table that we have to remember. Each and every outcome has to be remembered because this would be used while solving questions related to trigonometric angles, trigonometric ratios of these angles.